Yes, good evening to you too. My name is Sir Arthur Eddington. I was born in Kendal, England in 1882. My father died of typhoid when I was just 2 years old, and my early childhood was spent in poverty. However, I always performed well in English literature and mathematics in spite of my financial handicap. My success in mathematics earned me a scholarship to Owens College in Manchester in 1898. Shortly after I started college, I discovered my love for physics and astronomy. I finished a degree in physics at Owens and then went to Trinity College, Cambridge in 1902. Spent some time working there as a mathematics professor and conducting research in thermionic emission. Turned my focus to astronomy in 1906 when I was named the chief assistant to William Christie, the Astronomer Royal of Greenwich Observatory at the time. Around this same time, Albert Einstein was finishing up his theory of general relativity. Because I was one of the only Englishmen at the time that had the mathematical ability to understand his work, I was one of the first people to receive letters on his ideas when he completed it. And also, it was because I was one of the only ones to consider the work of a German during the strife of World War I. Because I have been a Quaker pacifist since birth, I tried to urge other British scientists to set aside their pride and consider the validity of this man's work. Few people agree with me, so I was the biggest supporter of Einstein's relativity in England. Because I could objectively consider his ideas, I was able to devise an experiment to help prove Einstein's theory. You see, Einstein had stated that if any one of three major concepts were to be shown false, then his whole theory would fall apart. One of these concepts was that light would bend due to gravity. After putting some thought into it and discussing with my colleagues, I knew exactly how I would test this aspect of Einstein's theory. Einstein's theory completely reworked our idea of why gravity affects objects in the way that it does. It was vastly different than Newton's ideas, which had been accepted for over 200 years. Newton had claimed that light would bend when passing a massive object, but Einstein's theory stated it would bend almost twice as much. This part of his theory, also known as gravitational lensing, is what we wanted to prove. Our idea for proving this aspect of his theory would be to measure the position of stars away from the sun and then compare that position to their apparent position when closely in line with the sun. The problem with that, however, is that there's no way of measuring stars that are close to the sun because they're always blocked out by the sun's brightness. However, there was a solar eclipse coming up in May of 1919, so I knew that would be the perfect time to perform these tests, as the sun's harsh intensity would be subdued by the moon. I observed that the highest star cluster would be just beside the sun during the eclipse, so I took some baseline measurements in the months leading up to the eclipse, while the cluster was still sufficiently far away from the sun. This prepared me to have a comparison to my measurements taken during the precious moments of the eclipse. My goal was to determine the apparent position of the star cluster while it was almost behind the sun, and see how much the image was shifted relative to my pre-measured baseline positions. The difference in position would either prove Einstein to be correct or show that Newton had been right all along. After I realized that the solar eclipse would be the perfect time to perform this experiment, I had to decide where in the path of the eclipse would be optimal. I wanted a place that was on the center of totality and had a longer duration of darkness. I also wanted a place that was far away from other people that could be a distraction or ruin the experiment. I wanted everything to be just perfect because I knew that there would not be another chance for a good long while. So after some research, I found a little island called Principe. This island is located off the west coast of the continent of Africa. There we would be in the shadow of the moon for about 6 minutes, just enough time to make sure we got some useful pictures. We also had a backup location in case Principe happened to be shrouded by clouds on the day of the eclipse. We had a secondary team set up in Sobral, Brazil, just in case anything went wrong. It was a good thing we did because the day of the eclipse brought heavy rain and thick clouds to Principe. The Brazilian team had some problems of their own. The tropical heat and humidity caused the metal in their telescopes to warp, forcing them to resort to smaller instruments, but they still got the job done. There was a lot going on in the world during the time leading up to our experiment. World War I played a tremendous role in whether or not Einstein's theory would be tested. As I mentioned before, most British physicists and astronomers would hardly consider the work of a German during the war. Whether they were too proud or felt like they were betraying their country or whatever was going through their head, I don't know. Not to blow my own horn here, but I certainly am glad that I was able to consider his thoughts objectively and consider him for the genius that he is, instead of just looking at him as some lousy German that didn't know what he was talking about. Luckily, the war ended just a few short months before the eclipse, allowing people to make peace and put aside their differences. It gave me just enough time to have some help in preparing for the day of the eclipse. The main other person involved in this project was, of course, Albert Einstein himself, the true genius that was able to realize the way the universe works. His mind is beyond belief. When I was working as the secretary of the Royal Astronomical Society, I was blown away when I received papers and writings regarding Einstein's new findings. One of my colleagues, a Dutch physician named Willem de Sitter, is the one who first sent me documentation of Einstein's research. He had a great respect for what Einstein had done, and he knew that I too would appreciate such an amazing set of ideas. There was plenty of people who had a part in making the fine points of this experiment come together, but certainly without the brain of Einstein, we would still be assuming Newton's ideas to be the factual standard. My role in this project was to be of assistance to Einstein by using my abilities and resources to test one of the main concepts of his theory. He had stated that light should bend when it passes closely beside a massive object. The more massive the object, the more gravitational lensing occurs. My job was to use my mathematical abilities to calculate how much the light from the Hyades star cluster shifted during the eclipse. I oversaw the process of making sure that everything was in line for my team to get adequate pictures and measurements during the few minutes of the total eclipse. Once they had gathered all the data, I crunched the numbers and analyzed the results. I then publicized my results and made it publicly known that we had confirmed part of Einstein's theory. The results of my experiment had an unbelievable impact on the physics community. Einstein's theory of general relativity completely revolutionized the way we look at the universe. For one thing, it made Einstein an overnight celebrity. People were blown away by the fact that Einstein had shown Newton to be incorrect in some of his findings. Newtonian physics still works for things like kinematics, but Newton's reasoning for why gravity behaves the way it does was off. Once we had seen that Einstein's theory was correct, it allowed us to conduct more experiments and research on outer space. Einstein's idea of gravitational lensing is now used in looking for planets outside our solar system. We can watch the stars and see when their positions seem to shift in the sky. This points us towards the idea that there is some massive object between us and the star, and gives us a good place to start looking for an undiscovered planet. However, not everyone immediately accepted our findings, and therefore didn't accept Einstein's theory. This stemmed from the confusion as to why I threw out some of our data. People thought it was because I saw that it didn't fit Einstein's prediction, but really it was only because of the Brazilian team's warped telescopes. I can assure you that our measurements were accurate. Our results have been repeated time and again, and Einstein's theory is now widely accepted. Do I feel like I've had a successful life? Absolutely. I am very proud of what I have accomplished. I feel like I have spent my time well. I feel blessed that I have had the ability to do the things that I have done. I am glad that I was raised as a pacifist, so that I had the mindset that allowed me to even consider a German's work in the wake of World War I. I'm proud to say that I was a key player in proving Einstein's theory. I know that he is the one that was behind it all, and it was his genius that discovered these concepts, but I still take joy in knowing that I had at least a small part in reworking the entire concept of physics and the universe.